In this video, we're going to talk about Le Chatelier's principle. Now, Le Chatelier's principle simply states that when a stress is placed on a system in equilibrium, the system will shift to minimize that. So that is Le Chatelier's principle. And there are four stresses that we can have to place on an equilibrium. The first is concentration. Pressure of our equilibrium system. The third is temperature. And in this class, we're really only going to, or in temperature, we're going to be looking at whether the reaction is endothermic or exothermic. And then finally, we can look at a catalyst. So when a stress is placed on a system in equilibrium, whether that stress is increasing the concentration, increasing the pressure, manipulating the temperature, or adding a catalyst, that system is going to shift to the reactants or the products to maintain the equilibrium and minimize the stress. In this class, we're really only going to be looking at the concentration and we manipulate the concentration, how the system will respond. So when we change the concentration of a reactant or a product, then the reaction is going to have to be forced in a direction in order to account for that stress. Remember, K is equal to the concentration of the products over the concentration of the reactants. So it will not change. So if I increase the concentration of my reactants, I increase the number on the bottom. That means in order to keep K constant, I need to make more products. So if we increase the reactant concentration, we will see a shift to the products. Of the products, that means we make the number on the top bigger, then I'm going to have to make the number on the bottom bigger in order to make K stay a constant. So if we increase the concentration of our X, then we'll see a shift. Anytime there's an increase, then it's going to go to the opposite side. Decrease the concentration of our reactants. We make the number on the bottom smaller. That means in order to keep K constant, we're going to have to see a to the reactants. We're going to have to make more reactants. So if we decrease the reactant concentration, we'll see a shift to the reactants. Concentration, or we decrease the concentration of the products, that means the number on the top is going to get smaller. So in order to keep K constant and not change, that means I have to shift the reaction towards the products so I can maintain K. It's going to shift to the products. System in equilibrium is placed under a stress. In this case, the stress is increasing or decreasing the concentration. K must remain constant. It is an equilibrium constant. So up is in the transportation of oxygen throughout our body, and it is regulated by the equilibrium of hemoglobin and oxygen. So oxygen is going to bind to hemoglobin, and in doing so, it gets transported throughout our body. If something comes along and disrupts this process, such as carbon monoxide, then it can really put a stress on the system. Carbon monoxide which can bind to hemoglobin at a much higher rate or much higher affinity than oxygen, then it's going to mess with our equilibrium system. So carbon monoxide is going to come along and bind with the hemoglobin. And in doing so, the concentration of hemoglobin. So if I decrease the concentration of hemoglobin, then according to Le Chatelier's principle, we will see a shift to, and what it means is we see a decrease of oxygen binded to the hemoglobin because it's going to shift towards reactants where we just have hemoglobin and oxygen. So that means we're not transporting oxygen throughout our body as much anymore, and that's how someone can have carbon monoxide poisoning.